Okay, here's another version of the TIPS experiment. A waitress randomly decided what to do with 80 dining parties. Notice the slightly smaller sample size here, or experimental size. There's four possibilities: no candy, or one piece, or two pieces, or this is the clever part: offer one piece, have one piece, and then a suggestion, an offer to take another piece. She recorded the tips received, very much like part number 23. And in general, what she discovered is the more candy, the higher the tip, but the highest tips came from the one piece plus suggestion scenario. Okay, so I can't, with this program, I can't easily draw a diagram of the experiment, but the main thing is you're going to start with the 80 dining parties, and then that's going to fan out, arrows fanning out to the 4 treatments, these 4 different possibilities, and make sure that you write random across those arrows, much as in the book, to make it clear that there really was a randomization procedure and it happened in that part of the process. For more complicated experiments, there might be 2 different stages of randomization, or might not be exactly clear. But we just want to emphasize, yes, it was a randomized experiment. That allows the methods of statistics to work on it. Okay, and then arrows going together to just recording the tips. Okay, pretty straightforward, hopefully. Okay, how many factors, how many levels? Well, there's only one factor. It's just the candy strategy. Okay, and so there's just one, and then there's 4 levels of that factor. You might, I don't know how easy it is to get confused with this. There's a certain strategy in terms of doing the candy, and there's 4 levels of that. There's 4 choices. Okay, when there's only one factor, the number of treatments is the same as the number of levels. It's just going to be 4. Okay, I don't know why I'm all capping that. Okay, the response variable is just the tip percentage. Okay, and we record that in each case. So they ask, is it blinded? Was blinding applied? Is double blinding applied? Okay. Well, they're not telling us explicitly about that. Okay. So it's not given explicitly, and very much like in number 23, it depends on when the waitress does the randomization. So first of all, there is some blinding, some very significant blinding that's applied, and that is that the customers don't know. They don't even know an experiment is going on, which is kind of the best kind of blinding. Okay, and it's probably ethical in this case. Often it's not ethical to have your subjects not know they're part of a psych experiment, but here it really doesn't matter. And then the waitress should make sure to choose randomly right before giving the check, and possibly with candy. Okay. As we said in 23, if she knew at the start, if she just said, here's a table coming in, I'm going to roll the die, or do whatever randomization procedure she has, right then it might subconsciously influence how she interacts with that party. It's actually quite likely. It's known that kind of thing can have a strong effect on interactions. So they're not quite clear on how much blinding there is, but it could hopefully be quite well single blinded. So that's single blinding, because remember, double blinding is when you have a concern about the evaluation of the response variable and if that might be biased. And there's not really much need for double blinding here, because it's not something that's very subjective. It's a single number, since the response variable is so straightforward. When it's a single number, it's very hard to imagine people fudging. If it's a complicated, like a subjective evaluation, that could be an issue. If it's a bunch of different numbers as a kind of a combined response variable, then you have an issue of, well, which one do you weight more strongly? How do you interpret everything? Here, it's a straightforward enough thing that you don't actually need for double blinding. So hopefully they did it right and did a very well single-blinded result, and we could hopefully really trust this result. Okay, and then F is really, I've already discussed that, and that's if she knows in advance the treatment. Okay, and so hopefully this was a carefully designed experiment where they realized that in advance that they did the randomization at the right time. Okay, I think that's all we need to say about this one. Nope, I think it's a nice little result, and it's not super surprising that that interaction of, oh hey, take another, you feel like, wow, that's a nice waitress, I'm going to tip her a lot. Notice the 23% compared to 15% seemed to be a baseline from another experiment. Now, you can't directly compare the experiments because there might be other differences, but it's suggestive that this is pretty strong. I'd like to see all the other numbers. I'd like to see the no candy result as kind of our baseline control. But anyway, 23% is pretty good. I think if I was going to be a waitress, I would do this.